Hey everyone, welcome to This Explainer. Today we're going to treat math completely differently. Less like boring arithmetic and a lot more like a secret language. And guess what? You are the cryptographer. We're looking at squares and square roots, but we're going to frame the whole thing as a codebreaker's guide to uncovering the hidden architecture of numbers. It's going to be a lot of fun. Okay, let's dive right into our roadmap for today. We'll kick things off with Section 1, the baseline, just to nail down those core concepts. Then we move to 2, the tells, where we'll look at the properties of squares. After that, my favorite part, Section 3, cheat codes for mental math. And we'll wrap up with 4, number magic, to uncover some genuinely mind-blowing hidden patterns.
All right, Section 1, the baseline, core concepts. Let's set the ground rule.
So, just as a super quick refresher to anchor us, a square is simply a number multiplied by itself, right? X squared equals x times x. We all know that 2 squared is 4 because it's exactly 2 multiplied by 2. It's an incredibly simple baseline rule, but you know what? It's from this exact simple rule that an entire universe of complex, really cool visual patterns emerges.
Which brings us to Section 2, the tells, properties of squares.
Now, think of this like being a detective. When we look at a crime scene, we look for clues, right? While in math, we can look for specific structural tells to instantly recognize what's going on. If we just scan the squares of the numbers 1 through 10, look really closely at the ones place. Those ending digits 1, 4, 9, 6, 5, 6, 9, 4, 1, and 0, this brilliantly illustrates something huge. Perfect squares only ever end in 0, 1, 4, 5, 6, or 9. And that little observation brings us to our first massive shortcut, which is the rule of exclusion. Because genuine perfect squares absolutely must end in those specific digits we just talked about, we know for a fact that numbers ending in 2, 3, 7, or 8 are literally never perfect squares. So if you're analyzing some massive data set and you spot a huge number, like, say, 79,288, you instantly know it's an imposter. It's totally faking it as a perfect square. There's another structural tell we can use, and it's all about how trailing zeros behave. Check this out. When you square a number ending in a single zero, like 10, it doubles to 2 zeros, giving you 100. If you square a number with 2 zeros, like 100, well, it doubles to 4 zeros. The rule here is that squaring always results in an even number of trailing zeros. So if you spot a number with exactly 3 trailing zeros, like 64,000, boom, automatic fake. Moving right along to Section 3, cheat codes, mental math. Time to hack some calculations. So, now that we know exactly what tells to look for, let's use these rules to completely hack our math homework. I'm going to issue a challenge to you right now. What is the unit digit of 26,387 squared? Seriously, look at that number. Are you really going to sit down and multiply that out without a calculator? No way. Ready for the reveal? The answer is simply 9. Yep, 9. You can calculate that entirely in your head in what, less than 2 seconds? Okay. Here is the logic behind the trick and how you bypass all that noise. The tens, the hundreds, the thousands, they're actually just a distraction. You only ever need to square the unit digit of the base number to crack the code. Our base number ends in 7, right? Well, 7 squared is 49, and the unit digit of 49 is 9. Therefore, whatever astronomically large number this whole thing turns out to be, it absolutely must end in a 9. Calculation hacked. And that perfectly sets us up for Section 4, number magic, hidden patterns. Let's see how this builds into pure mathematical magic. This is where things get really fun, and we start seeing the beautifully structured matrix behind the numbers. Let's decode the hidden spaces, living exactly between the squares. For example, how many non-square numbers live between 9 squared, which is 81, and 10 squared, which is 100? Instead of brute forcing it and counting on your fingers, use this incredible shortcut. Identify your first base number, n, which here is 9. Then, just use the formula 2n. Multiply 2 by 9, and you get 18. Bam! There are exactly 18 numbers living between those two squares. But wait, it gets even better. Now, what's really interesting about this next concept is how perfect squares are actually secretly constructed out of odd numbers. Look at this. 1 is just 1 squared. But add the first 2 consecutive odd numbers together, 1 plus 3 equals 4, which is exactly 2 squared. Add the first 3 odd numbers, 1 plus 3 plus 5 gives you 9, exactly 3 squared. It's wild, right? The exact amount of consecutive odd numbers you add together perfectly matches the sequence of square numbers. Okay, now for my absolute favorite pattern. We are going to construct a mathematically perfect, symmetrical pyramid. Let's start simple, just squaring 11s. 11 squared is 121. I want you to notice how the digits count up to 2 in the middle and then beautifully reflect right back down to 1. Let's take it a step further and add another digit, 111 squared. Without calculating it, what do you think it is? Just follow the pattern. It's exactly 12,321. The numbers logically count up 1, 2, 3, and then smoothly mirror back down to 1. Let's keep building this thing. 4 ones squared. The peak of our pyramid is going to be 4, simply because there are 4 ones being squared. So the answer beautifully lays itself out as 1, 2, 3, 4, 3, 2, 1, up to 4 and right back down. Let's blow it entirely out of the water and jump all the way up to an 8-digit number, 8 ones squared. Look at that massive sequence. We don't need a calculator for this. We literally just follow the visual logic we've decoded. The answer counts perfectly up to 8 and mirrors back down. 1, 2, 3, 4, 5, 6, 7, 8, then 7, 6, 5, 4, 3, 2, 1. This underlying architecture is just incredible, letting you instantly decode such massive complexity. So what does this all mean? Well, we've completely decoded the baseline rules today. We exposed the tells, we hacked the mental math, and we revealed the hidden pyramids within the numbers. You officially hold the Codebreaker's Guide to squares and square roots. So, I'll leave you with this final thought. If these basic math rules hide such beautifully predictable secrets, what other cheat codes are waiting to be cracked in our next chapter? Keep analyzing, keep questioning those numbers, and I'll see you in our next explainer.